Hey, what's up, guys? So your LONDO for today is students will be able to identify the x-intercept, the y-intercept, and determine the slope of the line given a graph. So I already know that this was covered in 8th grade, so we're just going to dive a little bit deeper into it. So let's go ahead and get started. And the way we're going to know if you were successful, I'm going to give you 4 graphs, and you have to get at least 3 out of the 4 problems correct to show that you have mastery. All right, so here's your anchor chart. Go ahead and pause the video if you want to just look at it. And so just remembering stuff from last year, the B is always going to represent your y-intercept. And so when you go here and you see this line, and so right here, that is your y-intercept. So I'm just going to label that right there. And importantly, when you're writing your points, you always want to write it as x comma y. So you want to look at where it lands on your horizontal axis first, and then go back and see where it is on the vertical. And then this one might not be talked as much, but this is the x-intercept where it crosses the x-axis. This is the x-intercept. Vocabulary that we're going to show for this year is going to be 0. So this is also known as a 0. And then more importantly, y'all worked with slope last year in the forms of rise over run. And so we're going to make a quick slope triangle. So if you notice here, I already got a few points established. And so I'm going to go with this one right here. So from here to here, my graph decreased how many units? So I'm going to count 1, 2, 3, 4. And then went over 3. And so this was down 4 over 3. And so my rise is -4 over 3. So that's how you can use your slope triangles, by counting. You always want to make a right triangle. Again, you notice here, this makes a right triangle. And it's always going to be proportional, so if you wanted to, you could always go down here, go across. Now, if we count again, this is 1, 2, 3, 4, 5, 6, 7, 8 units down, and then 6 across. And so -8 over 6 will simplify to -4 over 3. And so alternatively, you can always find your slope by taking those 2 points that you found and using the slope formula as listed here. So in the actual slides that you could use yourself, it will take you to the Desmos activity. So make sure you go ahead and take care of that as well. So this is just a link to it. And so make sure you go back and do that link. It's going to be part of your grade. So now here's the actual lesson. All right. I'm going to first show you how to annotate the problem, look at important vocabulary, the graph of a linear function n. So I need to go find where n is. Okay, that says it's n. Which statement about line n must be true? So I'm going to emphasize true. So I'm going to look at my statements first. The graph of n passes through the point 2, 3. So I'm going to go to 2, 3 first and put a point right there. 2, 3. Is that true? It is not. So it is false. That means that one is wrong. The y-intercept is located at 0, 3. Okay, so this is y-intercept. So if we go back to our anchor chart, it is where it crosses the y-axis. And so looking at this line crosses here, the y-axis, and that is the point 0, 3. And I'm going to label that the y-intercept. Since I know the y-intercept, I'm going to go ahead and just find the x-intercept also, which is right here. And that looks like it's 2, 0, and x-intercept. And again, another way to say or refer back to the x-intercept will be using the word 0. And so now that I see that my y-intercept is 0, 3, I know that this one is false as well. The 0 is 2. All right, so when I go back to, since I labeled my 0, it says 2. And so I would say this is potentially true. And now you notice here it refers back to the slope. So again, using your different methods of finding slope, I'm going to make a slope triangle from here to here. So it makes a perfect right triangle. And so starting from this point, the graph will decrease 3 units, 1, 2, 3. and it goes over 2. So using rise over run, that is 3 units down, 2 across. And so my vertical change again is going down 3. My horizontal change is 2. So my slope is -3 over 2, which lets me know that this is also false. Now, using a different set of points though, we could also still use the slope formula. That point is -2, 6. That's 0, 3. I'm gonna run with those points. So I got -2, 6, 0, 3. And you're gonna label your points x sub 1, y sub 1, x sub 2, y sub 2, using slope formula. We got y sub 2 minus y sub 1, x sub 2 minus x sub 1. Now I'm going to substitute everything. Now it's just as a suggestion down the road, you want to put everything in parentheses. And so 3 minus 6, 0 minus -2. And we put everything in parentheses so that way we can separate the minus from a negative. I know you guys could, no offense, get sloppy with your writing, but y'all slowly do this. Oh no, it's an equal sign now. So make sure to put it into parentheses. And at that point, you just simplify. 3 minus 6 gives me -3. 0 minus -2. So when you subtract a negative, that's actually a plus. And so that gives me 2. And so my slope is, again, -3 over 2. And so that's how you would do this problem. And again, we're emphasizing y-intercept, x-intercept, and how to find slope. So you have 2 ways to find slope at the moment. Here's a chart of my I-do, so that way if you want to go back and reference it. And here are your steps. And if you go back to the Desmos activity right now, you could practice one on your own. Yeah. All right, guys, and the second I-do problem for slope, x-intercept, and y-intercept, I'm going to go ahead and list those vocabulary and key features at the top. So slope, y-intercept, and just I guess a potential spoiler, we're not going to end up finding the x-intercept for this problem. But I'm going to go ahead and first read the problem. Jessie is a personal tutor. The graph shows the linear relationship between her weekly earnings and her number of hours worked. So those are our 2 variables right there. Based on the graph, which statement is true? So first off, I'm going to go ahead and look at my graph so I could figure out which one represents my x and which one represents my y. So I already have those established. This is on my x-axis, so that means hours worked are the x. So I'm going to put an x right here. Her weekly earnings is the y, so I'm going to put a y right there, and I'm going to put a y right there, so that way I know what I'm talking about. So I'm going to go ahead and look at my each statement to see which one's true. So Jessie charges a maximum of $400. Maximum. So that means my graph must stop at the number 400. So, and it's talking about weekly earnings. So I'm gonna go weekly earnings 400. That's right here. I'm gonna go to my actual line, and at 400, I see a giant arrow. Now we're gonna learn about domain and range later on. This is 6 weeks, but anytime I see an arrow, that means it's gonna keep going. So that means it does not stop at 400. So that means she could keep on working and earning more money. So she does not earn a maximum of 400. So that is false. Next one, initial fee of $50. Now, another word for initial: fee, initial amount, initial value. So I'm going to go ahead and write all those: initial fee, initial amount, initial value. That all means the y-intercept. So let's go ahead and look at the y-intercept of our this particular problem. So here's our y-intercept, our coordinate. Now it doesn't look like it's perfectly on the grid, but you could estimate that it is between 100 and 200. This says $50. So that means this is false. But now let's go ahead and give a ballpark range. That looks like to me it's going to be 0, 150. Next answer. Jesse only works 10 hours per week. Alright, so let's look at the number of hours. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm guessing this is 10. But when I go to 10 right here, what do I see again? I see an arrow. So meaning that she could work more than 10 hours, and just this graph doesn't show what's going to happen past 10 hours. So you can actually extend this line to keep on going. So that means this answer is also false, which leaves D as the only possible true answer. But let's go ahead and prove that to be sure. You need 2 points for slope. You always need 2 points for slope. There's a point right there, there's another point right there, and there's another point right here. So those points are 2, 200. The next one is 6, 300. And if you really want this extra one, this one is 10, 400. Now that I have my points, you can make a slope triangle. And so I'm going to change to a color. It's going to be slightly visible. And I'm going to erase the y-intercept first, though. So go ahead and write that y-intercept again at 0, 150. Y-intercept. I just needed the room for my slope. So I'm going to make a right triangle connecting 2 points. Alright, so I made a right triangle connecting those 2 points. My vertical change looks like it's only 1 unit, but I gotta pay attention to my increments. So I go from 200 to 300, which means I went up a total of 100 units, but it looks like just 1. Now my horizontal change, that is gonna be 1, 2, 3, 4 units, but make sure that you look at the increments. Those are going by 1, so that's actually 4. This is your change in Y. This is your change in X. And I'm actually going to color code that using a different color. So, and you write your slope as change in Y divided by change in X, which is equal to, my change in Y is 100. My change in X is 4. So 100 divided by 4 gives me 25. So that means my slope is 25. Well, let's say you don't like the slope triangles. Well, you got your 2 points already, and you can use that other one too if you wanted to. So the first thing you're going to want to do is label your points. So I'm going to go ahead and use this over here. This is x sub 1, y sub 1. Use a different color. X sub 2, y sub 2. Now remember the formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now I'm going to go ahead and substitute everything. 300 minus 200, 6 minus 2 And so that leaves me with 100 over 4, which also still gives you 25. So that means my rate of change is 25. And that proves, that also leads me to another conversation. Slope, another way to say slope is going to be rate of change. But rate of change is more used for real life situations because we're dealing with two variables changing with one another. And so remember, x is going to be your independent variable, y is going to be your dependent variable. Later on, it's going to be x is going to be your domain, and y is going to represent your range. But we'll get to more of that later. Make sure you watch the video if at any point you got confused. And so, thank you for watching.